in our last tutorial, we made a function to generate a figure, and to do that we wrote a function that accepts two parameters. These two parameters are two waves, display them, and then modify the graph in various ways. And that's a very simple function. You can do a lot more, however, through the use of flow control operations, such as if statements and for loops. So that's what we're going to talk about in this video, are if statements and for loops. If you can master if statements and for loops, you're pretty much good for graduate school in chemistry, as far as I can see, because they're very powerful. So let's make a function that includes those. Do figure if I say so. So we'll make this function is called do figure if flagged. So it's a little bit weird. You probably wouldn't write a function like this usually, but it's just to illustrate the concept. So in this case, we're going to accept the same waves as above, and we'll also include a variable parameter named doPlot. And we'll declare our waves as before. And we will declare our doPlot parameter as a int, meaning an integer, a whole number. Basically, that doPlot should either be a 0 or a 1. A 0 if we don't want to plot, and a 1 if we do want to plot. So let's start with an if statement. This is a way of asking a question, getting an answer, and then depending on that answer, proceeding accordingly. So let's say if doPlot is equals equals, this is the Boolean operator or conditional operator for is equal to, meaning if doPlot is equal to 1, run this set of instructions, and we'll actually reuse the code from above, and so we don't have to rewrite it. And we also want to accommodate possibilities of the value not being 1. So here we use an else if statement. So an else if statement is never on its own, always after following an if statement. This means if doPlot is 1, do this. Otherwise, check if this condition is true. And here we'll print, you did not want to plot a figure. And then finally, what if the user doesn't put in a 1 or a 0? Here we'll use the else statement, similar to else if, except there's no condition associated with it. It just accommodates everything that's not accommodated above. That just about does it for our if statement. Let's end our function. I'm going to go ahead and get rid of our figure so we can test this out. Do figure if flagged. And let's start by not plotting it. So we gave 0 for our third parameter, and as expected, IGOR output, you did not want to plot a figure. And that makes sense. Let's try and make a figure. Let's talk about it. If you're trying to copy something from the command line real quick, one thing you can do is use the arrow keys and browse to whatever line you want, hit enter, and it will reproduce that line of code. Save some time. Look at that. When we give it the 1, it actually plots it as expected. And just for due diligence, let's give it a -1. And we get our error has been accommodated. So if you want your code to be really nice, you should build into it error handling so that when the user erroneously gives, insufficient data or incorrect, poorly formatted, otherwise anomalous, you have code such that those errors are accommodated and the user can know what they did wrong. Otherwise, IGOR will just scream at them and they won't know what's up because it's not their code. So that is how you do if statements. Other forms of flow control using conditional operators are switches. We won't talk about switches, but they can be very useful. If you're interested, just check out the documentation on switches.